In this lecture, we will be starting with the design of induction machines. So first of all, we have to see the output equation of induction machines. So in one of our previous lectures, we have derived the output equation which is common for all the AC machines. And that equation was the output kVA rating Q is equal to C0 D square L into Ns. So we have the general output equation for AC machines. This is output kVA. Q is equal to C0 D square L into Ns. And the value of the output coefficient C0 is equal to 11 into B average into AC into kW into 10 raised to minus 3. So we have this particular equation. So in this particular module, even if we say the module name is design of induction machines, we are actually going to design induction motors. So induction motors. So now we know the case of induction motors. In case of a motor, the input is electrical energy and output is mechanical energy. So for induction motors, the output will be mechanical energy, but this equation that we have derived corresponds to the equation of electrical energy. So in this equation, this Q, output kVA, this kVA power represents the electric power. But in case of induction motors, the output is mechanical power. And also, when we are given with a question for designing an induction motor, the rating of the motor will be given in the question. Rating of the motor will be given, and that rating will be expressed in kilowatt. So we will be having the rating of the motor in kilowatt. And what is the rating? Rating means output power. So output power of the motor in kilowatt will be the data available to us. Okay, but we have the equation for electrical power in kVA. What we have is electrical power in kVA. Okay, we have the equation for this particular term. So we have to convert output power in kilowatt into electrical power in kVA. Okay, so where is electrical power in case of an induction motor? It is in the input side. So electrical power is in the input side, but we have the output power in kilowatt. So we have to convert output power in kilowatt into input power, and that should be in kVA. This is the equation for power in kVA. So we have to convert output power in kilowatt to input power in kVA. Okay, so for designing an induction motor, we will be having the required specification, that is required rating of the motor will be given in kilowatt. When a customer is demanding for a machine, the required rating will be given in kilowatt, that is output power requirement in kilowatt will be given. But if we have to find out the main dimensions and all, we need to use our output equation, and in the equation that we have, the power Q represents the input power expressed in kVA. So the parameter that we have, that is the output power in kilowatt, has to be converted to input power in kVA. Now, how can we convert this parameter? So we need to convert, first we need to convert output power to input power. How is that conversion done? So we know that efficiency is equal to output power divided by input power. Okay, so we can calculate input power as output divided by efficiency. So we will get the input power in kilowatt. Okay, input power in kilowatt is equal to output in kilowatt divided by efficiency. So now we need to convert this input power in kilowatt to input power in kVA. Kilowatt has to be converted to kVA. So how will you convert this? So we know that power factor cos phi is equal to kW divided by kVA. Okay. Cos phi is equal to active power divided by apparent power. So we will get the kVA rating equal to kW divided by cos phi. So input power in kVA will be equal to input power in kilowatt, that is output power in kilowatt divided by efficiency will give the input power in kilowatt. That term divided by power factor will give us the input power in kVA. And in case of an induction machine, this term is taken as Q. So in case of an induction machine, the output equation should actually be written as input power in kVA, that is Q, is equal to C0 D square L into Ns. Okay. So always remember, in case of designing induction machines, that is induction motors, the output power of the machine will be given in kilowatt in the question. So first of all, the first step in doing this problem, solving this problem, should be the conversion of that output power in kilowatt to input power in kVA. So how will you do the conversion? The given output power in kilowatt divided by efficiency into power factor. These two parameters will be given in the question, efficiency and power factor. So calculate input power in kVA, and then only you can substitute that in this particular equation. Okay. And if output power or rating of the machine is given in HP, how will you convert it to kilowatt? Output power in kilowatt is equal to HP, horsepower rating, into 0.746 kilowatt.